Hello everyone, welcome to this video. I talk about the reflection of light from curved mirrors. So here we'll see how the light is reflected to these curved mirrors. The curved mirrors are the mirrors that are bent to either inside or outside. So those curved mirrors are these the concave and the convex mirrors. So let's see the difference between these two curved mirrors. The first one is this concave mirror. Uh, the concave mirror is the spherical mirror whose reflecting surface is curved inwards. A good example of these are those the driving mirrors of a car, while the convex mirror is a spherical mirror whose reflective surface is curved outwards. So a good example of a convex mirror is a shaving mirror. So you can definitely differentiate between these two mirrors simply by saying that the concave mirrors are the spherical mirrors whose reflecting surface is curved inwards, while the convex mirrors are the spherical mirror whose reflective surface is curved outwards. The examples that concave mirrors example is the one that is used in driving those driving mirrors, and a good example of convex mirror is the one that is used in shaving. Moving on, let's see the terms used in studying these curved mirrors. Uh, these terms specifically will see how the light is reflected through them. Now we get these terms on how the light is reflected through them. So the first term is the center of curvature. The center of curvature, this is the center of sphere of which a mirror is part of. So the center of a sphere means that the center of that curved mirror is what we call the center of curvature. The radius of curvature, denoted by R, is the radius of a sphere of which a mirror is a part of. So radius of a curvature is double the focal length. We'll see what is focal length. So that is R is equal to F over 2. Moving on, the third term is the pole, denoted by P, the central point of a reflecting surface of a spherical mirror. So this is the central point, that definitely that point at the center of the reflecting surface of this spherical mirror. The other term is the principal axis. The principal axis, this is the straight line joining the center of curvature and the pole. So the line between the center of curvature and the pole, this means that the line from the center of the spherical mirror to the pole of this spherical mirror, that line is the principal axis. The principal focus, this is the point of on the principal axis where the light rays bend to the to intersect after being reflected. So principal focus, this is a specific point where after a line has been reflected through the mirror passes through. So this point is between the center of curvature and the pole, and it can be denoted by F. Moving on, the other term is focal length, as we've already seen before, that the radius of curvature equals to the focal length divided by 2. Now, what's focal length? The focal length, this is the distance from the pole of the mirror to the principal focus. So that distance between the pole of the mirror to the principal focus is what is called the focal length. Now, the focal length is definitely the half of the radius of the curvature. Moving on, let's see the mirror formula. This mirror formula, this is the formula that is used to show the relationship between the distance of the object from the mirror, that is denoted by U, and the distance of the image from the mirror, that is denoted by V, and the focal length, that is denoted by F. So the mirror formula can be shown as 1 upon F equals 1 upon V plus 1 upon U, whereby F is equal to the focal length, U is the distance of the object from the mirror, while V is the distance of the image from the mirror. Now, when using this mirror formula, there is a positive is real sign convection that is important to notice when you are trying to apply this formula in finding various in calculating the various these uh, questions related to reflection. So in a positive real sign convection, the following are to be considered before applying the values in the equation. The first one that the real image are given by positive sign, while the virtual image are given by the negative sign. So you definitely differentiate them when you applying the formula. By the distance of the real objects in the image are given by the positive sign, while the distance of the virtual image are given by the negative sign. Also, the real focus is given by the positive sign and the virtual focus is given by the negative sign. So you should be able to differentiate them when applying this mirror formula. Moving on, let's see the magnification. Magnification, this is the ratio of the image distance to the objective distance. Magnification is a unitless quantity which shows how much the image is larger or smaller to the object. So simply you can say that the magnification is the amount of how the object, the real object has been magnified or has been reduced due to the reflecting of light. So in this case, you can say that magnification is also defined as the ratio of the height of the image to the height of the object. So magnification simply is given by the distance of the image from the mirror divided by distance of the object from the mirror, shortly denoted by M equals to V upon U. Also, magnification also is given by the height of the image upon height of the object, simply given by M equals to HI upon HO. So therefore, we can simply compare the two, given that V upon U equals to HI upon HO. So in the equations uh, might be given maybe the distance of the image from the mirror and the distance of the object from the mirror. Also might be given the height of the image and might not be given the height of the object. So you can simply calculate the height of the object by using the comparison of the magnification. Moving on, you see the convex and the concave mirrors in our daily life. So here we're talking about the application of convex and the concave mirrors in our daily life. These curved mirrors are used simply as the first one in driving mirrors. Uh, these driving mirrors, as we saw before, that are fixed with these curved mirrors in order to help the driver to notice what is behind. Uh, the other application that in shaving mirrors that are used in those barber shops are simply that when you're shaving your hair to have a clear view on how the style of shaving can be. So this is the other application of the curved mirrors, and the other one are used as reflectors. So thank you for listening. I hope it's clear, guys. So see you in the other videos.